Well, good afternoon, everyone. Welcome to another edition of hydrocarbon refrigerants. The difference between a hydrocarbon refrigerant and this new R600. So let's go ahead and get started with our slide presentation. At the end, we will actually talk about the Encompass part supply website with the Easy Stock program, and we'll run off of that. So today, let's go ahead and skip this. As you can tell, this was started with an actual live class, which we had people. We had people that were actually sitting in a classroom. We've shortened this up a little bit. This one has. I thought that I had removed that slide, but evidently I didn't. So back in the 1900s, okay, HCs were used, and that they started using HC refrigerants, HC type refrigerants in the industry. Okay, in the 1930s, CFCs were developed. Okay, because they were non-flammable. Okay, HC use they started reducing the HC usage by the 70s. Guess what? They had discovered ozone depletion. Okay, so they found that all of these CFCs were causing a hole to in the ozone. So they started looking for different ways that they could combat this depletion of the ozone. Okay, then they came out with HFCs and the HCs. They started to replace again the CFCs because there was less of an issue with the HCs that they would have because there was no ozone depletion. I'll spit out in a minute. So then they came up with 134A, 212, a lot of the other HCs and the HFCs. Then in 2000 they launched HC ice cream cabinets. If you're familiar with Isomatic, they have a version. Taylor Freeze also has a version, and those are like your ice machine, your ice cream machines, and those cabinets. Like whenever you go to the I don't know of a place that is local to everyone that's all the way around the world. QT has their own machines. A lot of these small ice cream shops use an ice cream machine that has an HC product in the ice machine itself. So in 2005, there were over. I'm sorry, excuse me there. In 2005, there were over 50,000 HC cabinets in use in Europe. Okay, in 2020, over 500 million HC appliances were worldwide, and they were in use. So, are we going to stay with an HC until they come up with something better? That's exactly what's going to happen. Okay, so let's talk about the environmental impact. We were talking about R12. We're talking about R134A. Again, there's R600, and then there's the R290. Then there's the hot shot is what I call it. The 134A was used a whole lot in refrigerators, and then they were actually using 134A to blow it to use blow the foam into a refrigerator. That's some of the reasons that if you were using a meter that detected, if you were using a meter that would detect that there was a leak in the system. A lot of the times it would actually go off, and the problem was when they used 134A to blow that into the refrigeration cabinet, they had problems. It gave you a false reading. Okay, so R12 has an ozone depletion rating of 1. The GWP is actually 8,500. R134A is an HFC. It has a 0 ozone depletion, but the GWP is actually 1,430. So if you go to the 600 that we use today, which is an HC instead of an HFC or a CFC, okay, we have 0 ozone depletion rating, and it only has 3. So where you are actually probably headed next is probably going to go with either a 441A or a R7 170 is where we're headed today. So we have to get down to a base of under 300 GWP. Okay, so if you look at the way the chart runs, 2016, you can see that basically about 98% was the baseline of the 2,000 and under GWP, and then on today we're looking at at 2024 they have to have it under 1,200 GWP. Okay, and if you look at 2028, we have to have it under 600. Okay, it keeps stepping down, and we're slowly getting there, and we will hopefully get there and not lose too many problems. Okay, so refrigerant R32. It's an A2L classification. Okay, does it require recovery systems? Yes. Okay, R600 is an A3 classification. Okay, it doesn't require recovery right now. Okay, then R290 is an A3, and it's also not required to be not have to be recovered. Okay. So what happens with R600? Okay, it actually takes 3 things to cause a flame. Okay, you have to have oxygen, heat, and fuel. All 3 have to be present, or else you don't have a flame. But if I have fuel, which is the refrigerant, if I have the air, that's all the way around us, and if I have an ignition point, guess what? That's a torch. So I have the ability to have a flame. I was watching a program the other night, and this guy went to stick up this guy to steal his car at a gas pump. And the guy that had the gas pump in his hand just simply sprayed the gas pump, sprayed the fuel onto the guy. And, the guy goes, "I'm going to shoot you." And the guy looked at him and said, "You really don't understand the principle of the firearm, right?" He goes, "You understand that the first word in a firearm is fire." Okay. So, you have to have that pin that strikes, ignites the spark, and it's not actually the flame. I mean, it's not actually the gas itself that ignites. It's the fumes. So we have to make sure that we have to take away one of those, because you have to have one of those. Without it, you don't have a flame. Okay. Then we have a sudden release of refrigerant. What can happen? If you go out on YouTube and type in R600 refrigerant catastrophes, you will find there is one out there that GE product people at GE actually did. They took this to a field. They actually induced all three and filmed the results, and it blew up. It literally blew up. I have seen pictures of technicians that actually have burned their hands. There was a friend of mine that worked at a company in Atlanta, Georgia. They actually had a guy at the at the shop who brought a unit. He was the shop worker. He had a brand new guy with him. Didn't pay any attention that it was R600, and went to he recovered it, which he shouldn't have. But he went ahead and went to unsolder everything. Well, I don't know if you know this, but the oil in a compressor can contain up to about 50% of the oil can have the R600 in it. So you actually, if I am working and I have an R600 compressor, I am actually going to take and pour that oil out. Usually I'm going to pour it into a container that has kitty litter in it, that will absorb it. That will help get rid of some of the flammability of it. I'm still going to have to make very careful of what I do with it, because I still have the potential for ignition. Okay. So a flash fire, I can have a sustained fire, and that's simply a sustained fire is nothing more than it's one that is very difficult to put out. The last thing that could happen is the explosion. The explosion is the one that I just told you about, the GE one. If you type in R600 and go for catastrophes, it will show you some out there. Okay. All right. So if we go here and we talk about the LEL and the LFL, okay, R290 has a 2.1%. The R600 only has a 1.8%. Okay. So that's the LFL. Okay. The LFL is the lower flammability. Okay. The UEL and the UFL, which is R290 and R600A, those have the upper flammability limit. They're a UFL. So basically, everybody hates it whenever you say this, because it has a whole lot more in it than a lighter. But basically, R600 is super flammable. It's almost it's a member of the butane family, and everybody knows that about a butane lighter. So that's what they use. Okay. Okay. So who are some of the regulatory agencies that are associated and have a say so in what happens? The EPA, which is where you got your refrigerant license. The International Organization of Standardization, that's the ISO. You've heard of ISO 9000. That's one of the agencies. The National Fire Protection Agency that's the NFPA. That is actually that's actually one of the industries that we really need to that needs to have a little bit more say than they do now. Then we have UL, which is Underwriters Laboratories. Okay. The American Society of Heating, Refrigeration, and Air Conditioning Engineers. That's the ASHRAE. the European community, the Canadian standards, those are all out there. The American Society of the International Electrotechnical Commission, the IEC, are just few of the regulatory agencies that have say so in what's happening. Okay, so if I have a unit that has R600A on it, and if I've got this if I have my literally my model serial number, okay, that will tell me that I have what type of refrigerant charge they have on every single unit. There has to be a sticker on it. I will be back in 1 second. Okay, sorry about that. I meant to have this in here, but it started to rain and I took it outside. So on every R600A unit, I'm actually working on making a model. And so I have this R600 unit. And if you look right here, it tells you danger flammability. This is required. If you have any sticker and you don't show it, and if you work on it and you don't put a sticker back on it, guess what? They fine you. Okay? The EPA, I'm going to set that back down. The EPA has made it very difficult for you as a technician. They like to fine. So just make sure that sticker is on there. You also have to have it on the back of the refrigerator. Okay. So it tells me what's on this, tells me that it's an R600A unit. Okay. It tells me that the charge, the type of refrigerant, by the regulations, no retrofitting. You can't retrofit. You can't take an R600A out and put an R134A in. You can't. All labels have to meet and match the UL listing in it. There also is this sticker that's at the top. Should be above where you're on the back of the unit if it's a refrigerator. So if you don't have it and you don't see it, go to your truck and get you a sticker and put it on there. Every person should have a roll of stickers, both that flammable sticker and this danger risk of fire explosion. Okay. Because we all know that customers get out there and they start messing around with something and they get into something and then they don't know what they're doing. And, it used to be that they would release R134A refrigerant into the atmosphere. That only cost them about $10,000 about 3 years ago. Now it's $50,000. So you have got to be sure that you have everything done and you have your I's dotted and your T's crossed. Okay. This is the picture of my refrigerator. Okay. So if you look at it, this tells me what the model number is, what the serial number is. It tells me that it has R600 refrigerant in it. It tells me the charge that is in there. It also tells me, this is something that you really pay close attention to whenever you're a technician and you're looking to see what it is. It tells me everything that I need to know. Okay. So here are some of the safety resources. AHAM, Association of Home Appliance Manufacturers. That's the most familiar, most everybody knows AHAM. You know, you've got area, you got RSES, you've got gig. I'm sorry, GIZ. That is one of our fellow people in Germany. ARA, and then we have ARIB. Okay. So I'm going to tell you that if I am working on a refrigerator, anything that contains R600, I'm going to have three things with me. Okay. I guarantee you that I am going to have a fire extinguisher. Okay. Not only does it have to have a fire extinguisher, it has to be a certain kind of fire extinguisher. It has to be a dry powder fire extinguisher. Okay. It's required for transportation if you have any of it in your truck. So just take it with you whenever you go in. This is a pretty big bottle that they show. They have some smaller ones. Okay. The other thing that I'm going to have is I am going to have a combustible leak detector. Okay. I am going to make sure that I have that. Okay. If I'm going to use the Vulcan Lokring system, I'm going to have a tubing cutter. I've got to have a well-ventilated area. I'm going to have to eliminate any ignition sources. Okay. We're going to get a little farther into the ignition sources because there are a whole lot of other things. Now, at the very beginning, I told you that I would have at least three things with me when I walked in to the house if I was going to change it. Okay. If it's got R600, I'm going to have a fire extinguisher. I'm going to have the combustible leak detector. The other thing that I'm going to have is a fan. Most of the time, whenever you buy nowadays, if you buy a tool set, your drill set that has, it has one, the regular drill, the other one is the torque driver. One of them usually is something else, and then they have a light. Okay, so the other thing that they also have started including is a fan, which is really great because now I can use the same battery for my drill and put it in my fan. Okay, so let's talk about obvious ignition sources. Okay, burning materials, cigarettes, candles, anything that has a flame. Okay, if I strike a match, that's a flame. Okay, things that people don't think about are toasters, ranges, dryers, and it's electric and gas. It's not just electric. Okay, so anything that I can have that will heat something up. Okay, it gets hot and somebody turns a toaster over and on while I'm in there trying to evacuate a system. That there's the chance of explosion. Okay, some of the things that people don't think about. If I have a vacuum pump or recovery equipment or any of that is brushed, that has brushes in it, I need to find something that is brushed less. Okay, that is my chance for ignition. Okay, timers, switches, contactors. So if I go to the stovetop and it happens to be a gas stovetop, and and somebody clicks it on, guess what? That clicking sound that you always hear, that's a igniter, and that's trying to get the gas to it. And then if I've already got gas in the area, it'll ignite. It's the reason you have got to keep a fan going so that it keeps the area dissipated for any fumes that could be there. Some of the other things, torches or your spark igniter, that's That could be, that's the reason you don't use a torch, or because most of the time somebody is either going to use the spark igniter, or they're going to use a cigarette lighter. Right there, the wrong thing. Okay, static electricity. People don't think about that. We're getting to be winter. Guess what? Static electricity goes crazy in the winter. You know, everybody thinks it's funny whenever you walk around and you charge yourself up, and you and your partner there, and you tap him on the ear and pops his ear. You know, it hurts there for that split second. But if I've got static electricity and I have R600 that is highly flammable, I run the big risk of it igniting. Okay, so leak detection and line repair. What do we use? What do we do? How do we detect leaks? Okay, how about line repair? Okay, so I'm going to use a tubing cutter to remove any of the components that are bad. Okay, I'm going to use a soap bubble detection system or a certified leak detector. Okay, one of the things, I've got my leak detector that I've already got laid on the floor that's beeping. Why don't I just use that? I don't need soap bubbles. Okay, dry nitrogen only. Never use anything but dry nitrogen in it if you're going to test it. Okay, constantly monitor for a flammable environment. Okay, leak detection and line repair. So I'm going to purge the gases to an exterior environment. That doesn't mean into the immediate area. We already have too many things in the area that are ignition points. Okay, I've got to get this outside. The other thing is, I have heard a story of a technician that was doing this at an apartment complex. They didn't allow smoking, and they didn't allow it, you know, as you walked up the sidewalk, they didn't allow that. So what were people doing? They were going around somewhere else and smoking, and this guy was purging his R600, and this guy was smoking a cigarette and happened to walk up under him. Guess what happened? We had a problem. They almost burned down the whole building, okay, before the fire department could get there. So do not use an external heating source, okay, to defrost. You can't use if I've got to defrost something, I can't use my handy trusty heat gun, or I can't use my steamer, because those all have a spark. Okay, my heat gun it's what it says it is. It heats up, and that gives me a risk of I can, you know, hurt myself or hurt the customer's house. Do not use compressed air or oxygen for flushing. That goes without saying. Oxygen is one of the things that's required for it to for out of the triangle that we showed. You know, it's gas. It's an ignition point of some kind. Okay, and so we just want to make sure that we get rid of that. After we get done, all right, I am required with R600 to paint red marks on the access fittings. Okay, always remove your piercing valve. You cannot. Nobody should be leaving this has been since the 80s. It was illegal to leave a piercing valve on the unit itself. Now, everybody goes, well, what about the piercing valve in that comes on the filter dryer? Well, you can take and tape that piercing valve, and then seal that up, and then turn it a quarter of a turn, and that makes it okay. Okay, so a lot of times, whenever people are doing lock prep, they're seeing this, and they're thinking that, oh my gosh, I've got a leak. My lock prep, it didn't seal right. But if you look at this one, this is actually had way too much lock prep on it, if you look at it. So the lock prep itself fluoresces in a bluish green color if I'm using a UV light. Okay. Common refrigerant dyes fluoresce as a bright yellow. We've known that for years. That's the way that I used to check to make sure that if I had a unit and I thought it had a leak in it, one of the ways that I would do is drop in a little dye into it and see if it would let it go through the system, come back the next day, check it, and I could find where the leak was. Okay, so those UV dries, those are the fluorescent, and they show up yellow. Okay, the environmental conditions are the lights are off. Of course, you would always want to have them off if I am using a UV light. Okay, recharging and replacing the refrigerant. This right here, this is basically what I have to have to come in and replace a compressor. Okay, the only other thing that I've got to have is my tool, and there's two different kinds of tools. There's the manual tool that I have to do this with to get it to seal, and then there's the other tool, which is if I was going to still be doing refrigerant recovery and I was going to do it for a living, I would definitely have the automatic tool. So I stick it in, I make sure that it's that I have it sealed on both sides on the valve, and then I press the button and it compresses it itself. Okay, so the first thing I'm going to do is I'm going to match my refrigerant type, and I'm going to charge it to what the label tells me it should be. Okay, I'm going to repair all the electrical faults, secure power and discharge all capacitors for service. Okay, I'm going to make sure that the system remains grounded. How does that do that? I'd have that whenever it's plugged in. You can't let them cut the ground plug off. The lines are not exposed to a corrosive material. If I have to use the air and I have two light metals, I have to treat that as corrosive material because of the atmospheric conditions. So I will have to shrink wrap that. Okay, I'm going to renew the seals and the sealing material. If I'm going to use lock prep and I'm going to go to the filter dryer, I'm actually going to drop a little drop of lock prep on it, and I'm going to spin that around, and I'm going to seal that and then turn it for a quarter of a turn on the filter dryer. Okay, refrigerant removal. Okay, I'm going to tell you right here, that is not the way to do that. I hate to tell whoever made this slide, because it looks like it's in the down position. And if I were to try to do that, that every filter dryer has decadent in it. My decadent beads would block. I would never be able to get all of my refrigerant out. Okay. I'm going to maintain my ventilation, like I said. I'm going to make sure that everything is properly grounded. I'm going to make sure that I have venting of some kind. I'm going to have a temporary vessel for release. I'm going to have combustible hoses, and they have to be at a sufficient leak. Okay. After servicing, there's the sticker. Okay. I have to have my safety labels. They have to be in place, intact. They can't have a bunch of scratches through them. It has to be a good thing. I have to put my red markings on my process tube. That tells somebody that I have been in there and we have already replaced something in the system. Okay. I have to install ventilation features that are intact. The compressor oil may contain residual refrigerant. 0 PSI does not always mean 0 refrigerant. I will guarantee you that. Never has. Okay. So I'm going to stop right here for just a minute. Does anybody have any questions? I realize there's only 3 of us in the class, but does anybody have any questions so far? I'm going to give just a second for you to do this because this program is one of the shorter programs. We'll be here out of here in about another probably 10 to 12 minutes. Okay. I don't see anybody that has any questions, so we're going to go ahead and move along. Okay. So this is the charging kit that I get from Lokring. Okay. It has a compact digital scale. It has an LP and an HP valve manifold gauge. So that's low pressure, high pressure. R600 extraction valve. Okay. It has liquid extraction disc. It has ball valves and T's, valve core depressors, hoses, and then if you look at the very top, you notice they don't mention this. Right there is a manual. Keep it with you at all times. Do not throw it away because somebody needs that. It shows you exactly how to hook everything up in line. So make sure that stays with your kit. The other thing that is in this kit, sorry about that, I leaned back, is a purge, okay? If you use that, you have to, if I use that, I am going to make sure that I'm going to purge that to the outside. There is talk that they're going to remove that and they're going to put a bag. Whirlpool back whenever 134A started to come really big, Whirlpool came up with this great idea to have a bag. Now the bag that Vulcan uses is a much better bag than the Whirlpool bag used to be. Okay, but it was a bag that I could fold up and put it in with my tools, and it took up a whole lot less space than an extraction than the tank. So I like this. So refrigerant discharging on the working compressor. Okay, I'm going to perform a safety check. Once again, what's my safety check? I'm going to make sure that I have no combustible materials anywhere around me. Okay, I'm going to monitor with a leak detector, run the refrigerator for 5 minutes to warm up the oil, and then unplug it from the outlet. Getting this refrigerator to run, it helps to get rid of some of the refrigerant that's mixed in with the oil. Okay, I'm going to install a suction gauge manifold, discharge hose to the piercing valve, route weighted end outside, and then pierce the dryer. Okay, like I said, today they are now moving away from this discharge hose, and they're going to have you use your gauges, and discharge it into the bag. Okay. One of the other things that I have to do is pinch off the capillary tube. Okay. So I'm going to be confirming that the gas discharges. Once I confirm that it's discharging, I'm going to start the unit, and then I'm going to monitor the suction pressure. I'm going to achieve a minimum. I'm going to achieve a minimum of stabilized atmosphere. I'm going to unplug the unit, remove both pliers, and perform the service that I need to perform. Okay. So what am I going to do for Lokring on a non-working compressor? I'm going to check the safety around me, and then I'm going to monitor it. Once again, I've got my leak detector. I'm going to check around and make sure that I have no combustibles that could cause an incident. Okay. Then I'm going to connect to the system the same as you did the other way. I'm going to confirm the gas is being discharged. I can only do a passive recovery, so no external heat source. I'm going to close all of the open port prior to transporting. Okay, I'm going to connect both sides of the system as required. If I have a system restriction, okay, I'm going to have to use a passive discharge, which is an assisted discharge, passive discharge, an assisted discharge, and then I'm just going to keep repeating until I can get all of the stuff out. Okay, so the problem is trying to get all of that trapped refrigerant out. Because once again, this is highly flammable refrigerant. So this is the proper way to hook up. This is the actual picture that is inside your Lokring kit. Okay. So this is what it is. This shows you right here that if the unit has over 40 grams to charge, okay, I'm going to use the liquid adapter. If I'm going to just use my regular cylinder and hook into the charging valve, I can charge on the low side. So you're going to connect it as you see it here. You really need this. That's the reason I say always make sure that you have that you leave that in the kit itself. Okay. So I'm going to warm up my vacuum pump. Once again, it's a brushless pump. Cannot be a brushed pump. Okay. I'm going to use the extraction tool of adapter valve, and I leave it closed. I'm going to open all the remaining valves. I'm going to record the lowest vacuum reading that I get. I'm going to perform a leak check by isolating the vacuum pump and then the vacuum pump anti-siphon device. Okay, once I do that, I'm going to open the core valve depressors. I'm going to conduct an evacuation to a minimum of 29.9 Hg vacuum is maintained. Okay, so that's whenever the meter pegs at. It's 29.9. I'm going to isolate the vacuum pump. I'm going to monitor for pressure rise. If none, then the system is ready to charge. So I sit and I will let the system sit there for at least a minute or two. That way I know for a fact that I don't have any leaks. Okay. If I'm going to have if I have to charge this you charge this on the high side, I've got a system that's over 40 grams. Okay. I'm going to close the manifold, the high pressure manifold. We're going to close the ball valve extension adapters, which is shown right here. And then the ball valve to the vacuum pump remains closed. Okay. Then I'm going to come in. I'm going to zero my scale out, place the bottle on the scale, tear it to zero, open the extraction valve on the bottle. Do not remove the bottle from this point on. You have to leave the bottle exactly where it is. Don't pull it off and put it back on, because it will mess the whole charging system up. Okay. Then I'm going to open this ball valve. I'm going to half fill the charge, energize the compressor, cycle the ball valve until the charge is reached. Okay. Close the extraction valve, open the ball valve once greater than 0 bar PSI is reached. Then I'm going to close the low side manifold. Okay. So once again, it's not recommended for charges under 40 grams. So if I charge above 40 grams, which is what we did, we have to liquid charge it. Okay. So I'm going to close the high pressure manifold. I'm going to close the ball valve to the extractor adapter. My ball valve to the vacuum pump still remains closed. I'm going to install the liquid extraction disc, place the bottle on the scale and tear that to 0. I'm going to open the extraction valve at that point, pre-charge the ball valve, then open the valve to fill the to fill at least a half charge. Then I'm going to close the valve. Cycle the ball valve rapidly until you got it fully charged. Close the extraction valve, open the ball valve, wait 1 minute, and then you can start the compressor. Okay. So if I'm going to remove the charge, I'm just going to verify the compressor is running, crack the valve open to the valve core depressor at the filter dryer, open the HP manifold, high pressure manifold valve, slowly open the low pressured manifold valve until both gauges read the same pressures, close and remove the valve core depressors. Okay. This is, at this point, we should be good. Okay. Close the valve core depressor and remove it. Then I'm going to apply Lokring prep to the threads, which he's doing right here on the right. Install the caps. If a more permanent seal is desired, crimp the tube near the Schrader valve. Okay. Apply red paint to the service port. That lets somebody know that you have been in there. Okay. If you have any other questions, go to the website, www.vulcan.com.